When talking about quadratics, there's a couple different forms that it can be written in, and the first form that we're going to use is vertex form. So we're going to talk about vertex form and transformations for quadratic functions. The vertex form of a quadratic function is the function is x times the difference between x and h squared plus k. So h and k are both going to be numbers. HK is the vertex of the graph, and the reason they use h and k instead of like x and y is because there's already going to be an x, and this is the same thing as y in the graph. You don't want it to get confusing, so we used h and k as the x, y coordinates of the vertex of the graph. So in a quadratic parent function, looks like this. This is called a parabola. The vertex is that spot at the very bend, the middle point of the graph. So it starts there and it goes up on both sides. The parent function of a quadratic is f of x equals x squared, okay? Where I'm not adding, subtracting anything to the x before squaring it, I'm not multiplying it by anything, and I'm not adding anything to it after it's squared. It's just x squared. Okay, so when the equation is in vertex form, you can graph it quickly because you can see any transformations. What that means is that each letter in here represents a movement that the graph could make. So if a is negative, for example, the graph reflects or flips upside down. It flips over the x-axis. If a is a fraction, then the graph shrinks or is shorter. If a is a whole number, then the graph stretches or gets longer and skinnier. Okay, that's how a affects the shape of the graph. H affects the position of the graph. If h is a positive number, the graph moves left. If h is a negative number, it moves right. Now that's kind of opposite what you would think, because you think positive moving to the right, negative moving to the left, but this has this minus sign right here, which means go in the opposite direction of what it looks like. So if it's x minus h, that means h itself is a positive number. So if h inside this equation is positive, then it moves to the left. If h inside this equation is negative, then it moves to the right. If you pull h out and look at it on its own, positive moves right and negative moves left. The axis of symmetry is the line that cuts the graph directly in half. It's something that if I put it through it and wanted to spin that function, it would spin around it. The axis of symmetry is always at x equals h. It's a vertical line at x equals h. The last thing that will affect the position of the graph is k. K is added on to the end. It's always outside of the parentheses. If k is positive, the graph moves up. If k is negative, the graph moves down. Simple as that. So inside the parentheses affects left and right. Outside the parentheses affects the up and down of the graph. This affects whether it's happy, positive, smiling up, or negative, sad, smiling down. Okay? So in a rare case where x itself is negative and there's a negative inside, the graph reflects across the y-axis and the h will move in the direction of the sign that's in the equation. That's going to be a very rare occasion though. So let's just look at some examples. So in the function f of x equals x squared minus 2, or x minus 2 squared plus 4. There is nothing written in the a spot, so a is going to equal 1. Right here we've got negative 2, so h, in this case, this is negative inside the equation, meaning it moves to the right 2. And then we've got a positive 4 on the end, so k is going to equal 4. So h, you've got to change the sign from in the equation to out of the equation. So h is not negative 2, but positive 2. All right? So when a is 1, there's no stretching, no shrinking, no reflection. You're not changing it in any way that a could possibly change it. Since h is 2, it's negative inside, that means I moved the opposite direction. So instead of going left, I'm going to move to the right 2 places. It's the opposite direction of what you might think by looking at the equation. Since k equals 4, it's a positive number, the graph moves up 4 spaces. So here's what happens to this thing. All right, the original is here, so I've moved to the right 2 and up 4. As if I could pick this up and move it to the right 2 and up 4. That's my new graph. In the table, I added 2 to all of my x values, and I added 4 to all of my y values, and I'm able to get my new points on the table that way. Let's look at some more examples. We're typically going to be looking at the graph. So this one says f of x equals 2 times x plus 1 squared minus 1. So a is going to equal 2, so I'm going to stretch it by 2. This means I'm going to move it to the left 1 because that's left in and out, and this means I'm going to move it down 1. This is what we would write if I asked you to describe the transformations. Stretch by 2, left 1, down 1. Stretch means I multiply the y value by 2. So, and then I wrote those here. So if I take a look, I started at 0, 0. So the y value is 0, so I don't change it. So it's still, that's the stretching part. I multiply y by 2, it's 0, so it stays right there. Once I've changed it to 0, I move it down 1 and to the left 1, and my new vertex is right here. This was the point 1, 1. Right? So I'm going to take that point 1, 1, and I'm going to multiply the y value by 2. So the y value is 1, multiply that by 2, it goes here. Then I move it left 1, down 1. There's my new point. This was the point negative 1, 1. Multiply it by 2, I take it up to 2. Left 1, down 1. That's how I landed right there. This value right here was a y value of 4. It's the point 2, 4. Multiply that y value times 2, so that moves me from here up to there. Then I move left 1, down 1. Draw my dot. This was a y value of positive 4. I move up to 8, left 1, down 1. That should be right here as a matter of fact. So this point should have come up. Okay, so move up to 8, then left 1, down 1, and that's my new graph right there. So let's look at another example. So looking at just the function first, this is a equals negative 1. That means I'm going to reflect it over the x-axis. This means I move right 2. This means I move up 2. These two numbers won't always be equal. It's just how it's worked out. Alright, so my parent function is here. Okay, so I'm going to take my y value and multiply it times negative 1. Well, 0 times negative 1 is still 0. Then I'm going to move right 2, up 2. Draw a dot. Right here I was at the point 1, 1. Well, I'm going to take the y value of positive 1 and multiply it times negative 1. It comes down here. Then I move right 2, up 2. Draw my dot. This has a y value of 1. Multiply it times negative 1. Right 2, up 2. Draw my dot. This had a y value of positive 4. Multiply that times negative 1, and I come down here to negative 4. I move to the right 2 and up 2. Draw my dot. You do that with each one. You deal with your a by multiplying your y value by a. Then you move right or left, depending on what's inside here. Then you move up or down, depending on what's there, and you connect the new dots. So here's a picture of 5 different functions. I had to count them real quick. The first one, the one in black, is my parent function. My points are at 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, positive 4. Okay? This is the pink one. It says I moved to the right 5 and up 3. So I took each of my points and I went 1, 2, 3, 4, 5 and up 3. Draw a dot. 1, 2, 3, 4, 5 and up 3. Drew my dot. 1, 2, 3, 4, 5 and up 3. Drew my dot. I did that with each one of the parent function points. That's how I know how to graph this one. This is an h of x equals x squared minus 2. Now there's nothing inside the parentheses because there's no parentheses there. That pretty much means that my h value is 0. So I don't move it left or right if there are no parentheses. But my k value is negative 2, which means I move it down 2. So I took all of the points from the black function, the black graph, and just moved it down 2 spaces each time. Just move it straight down. Okay? For my orange graph, there's no parentheses, so I don't move it left or right. There's nothing being added to the end, so I'm not moving it up or down. I'm just taking each and every one of my y values and multiplying it by negative 2. So 0 times negative 2 is still 0. Positive 1 times negative 2 is negative 2. Positive 4 times negative 2 is negative 8. And so on. And the last but not least, this is the negative 1 that's out here. It tells me I'm going to flip it upside down, or I'm going to multiply all of my y values by negative 1. I have a positive 5 inside the parentheses, so I move left 5. I have a positive 1 outside the parentheses, so I move up 1. So my y value is 0. times negative 1 is still 0. Then I'm going to move to the left 5, up 1, draw a dot. At 1, 1, I'm going to multiply 1 times negative 1, so that takes me to negative 1, over 5, up 1, draw my dot. Positive 1 times negative 1 is negative 1, over 5, up 1, draw my dot. This is a positive 4 times negative 1 takes me to negative 4. Then I move to the left 5, up 1, draw my dot. And this method works every time. Alright, so this just covers back to f of x equals x squared is my parent function. Nothing's being added to the x, so there's no left or right. Nothing's being added after squaring, so there's no up and down. Nothing's being multiplied in the front, so there's no stretching, streaking, or flipping. That is why it is my parent function.